Okay, so let's look at a weird function. It's a fairly simple function, but it's not given by any sort of single formula. It's called the Heaviside function, h of x, and for values of x that are negative, the Heaviside function is equal to 0, and for values of x that are greater than or equal to 0, positive or 0, the Heaviside function is equal to 1. So here's the graph. To the left of 0, the function is just equal to 0. To the right of 0 and at 0, the function is equal to 1. And so I draw an open circle at the origin to suggest that the line approaches this point but never hits it. I draw a closed circle up here to say that the line approaches this point and hits it. Okay, so we can ask the question, what is the limit as x approaches 0 of h of x? Well, graphically, let's look at this. As we let x approach 0 from the right, it looks like we're approaching this point right here. What is the y-coordinate of that point? 1. So from the right, it looks like that the limit should be 1. As we approach from the left, the function is always equal to 0. The y-coordinate of the point that it's approaching is also 0. So from the left, it looks like the limit should be 0. Does that mean that the limit is both 0 and 1? No. A limit is a unique number that the function approaches. This function does not approach a single number, it approaches two of them. So we say that the limit does not exist. So it seems kind of silly for us to not say that the Heaviside function is approaching any values. It really looks like it's approaching both 1 and 0. But the thing is, we have to restrict the direction that we're approaching 0 from in order to be able to say that. So that motivates the idea of the right-hand limit and the left-hand limit. The right-hand limit, denoted by the limit as x approaches c, we put a little plus in the superscript above c, of f of x. It's the same thing as the limit, except we only compute it using values of x that are greater than c. The left-hand limit, which is the limit as x approaches c, and we put a little minus sign in the superscript above c, of f of x. It's the same as the limit, except we just compute it using values of x that are less than c. So the right-hand limit means we're coming from the right. The plus means we're coming from the positive direction. That confused me when I first learned it. I thought the plus meant we should be moving in the positive direction. It means we're coming from the positive direction. The left-hand limit, coming from the left. The minus sign means we're coming from the negative direction towards 0. So looking at the Heaviside function, if we restrict ourselves to values of x that are bigger than 0, and we approach 0 from the right, the point we approach has a y-coordinate 1. So the limit as we approach 0, it's supposed to be a 0, from the right of the Heaviside function is 1, and the limit as we approach 0 from the left of the Heaviside function is 0, because the value of the function is 0 to the left. Okay, so now let's talk about graphical conventions and evaluate some limits using a graph. First of all, when I draw an open circle, that means that that point is not part of the graph. However, if I draw a curve going up to that, that means that the curve is approaching that point, getting infinitely close to that point, just not touching it. A dark circle means that the value of the function, or at that point, is part of the graph, so therefore, for example, the value of the function at 1 is equal to 2. This point does tell us what the value of the function is. If I draw a line going up to a dark point, that means that the function itself approaches that point as we approach that x value. If I just have a dark point sitting off by itself, a closed point like this guy down here, that just means that for whatever reason, the function decides to have a hole here and jump down here for a second and then pop back up. Okay, so let's evaluate a bunch of limits. So first of all, what is the limit as x approaches 1 from the left? That's what the minus sign means, of f of x. Well, as we approach 1 from the left along this curve, we approach this open circle right here. So since the graph touches this open circle, that means that the limit as we come from the left side approaches the y-coordinate of this open circle, which is 1. Now from the right, which is what the plus exponent means, that means we're approaching 1 from the positive direction. As we approach 1, the graph approaches this filled-in circle right there, which means that the y-coordinate of that circle is equal to the limit at 1, which is 2. Now, since this circle is filled in, that also means that the value of the function at 1 is equal to 2. So in this case, the function is equal to the limit from the right. It's not equal to the limit from the left. Okay, let's look at 2. Now, as we approach 2 from the left, we approach this filled-in circle, which has y-coordinate 3. So that means that the function goes to 3 as we approach 2 from the left. As we approach 2 from the right, the graph approaches this open circle, which has y-coordinate 4. So the limit from the right is 4. What is the value of the function at 2? Well, we go to the closed circle for that. That has y-coordinate 3, so the value of the function at 2 is 3. Finally, let's look at this point right here at 4. As we approach 4 from both the left and the right, we approach this open circle. This open circle has y-coordinate 3, or at least it's supposed to. So that means that the limit from the left is equal to 3, and the limit from the right is equal to 3. However, the value of the function at 4 is the y-coordinate of the closed circle, which is 1. Now let me note that in this case and in this case, there is not a two-sided limit, a normal limit, as x approaches 1 or as x approaches 2, because the graph is approaching two values as we come from the two different directions. However, at 4, since the limit from the left is equal to the limit from the right, the typical, usual two-sided limit also exists, and it too is equal to 3. Okay, so the question for this video: please draw the graph of a function f of x such that the value of f at 0 is 0. The limit as we approach 0 from the left is equal to -1, and the limit as we approach 0 from the right is 1. It can look like anything you want so long as it satisfies these three things.